Hi everyone, today we will be solving question number 9 from May 2022 AAHL paper 1, and this is from time zone 1. So we've been given two complex numbers Z1 and Z2, and then we've been asked to find an expression for Z1 and Z2 in terms of B, where B is a real number not equal to 0. So let's start with part A. In part A we need to multiply the two complex numbers. So this is 1 plus BI multiplied by 1 minus b squared minus 2bi. So multiplying this out, we will get 1 minus b squared minus 2bi. Then bi times 1 is just plus bi. Bi times negative b squared is negative b cubed I. And plus bi times negative 2bi squared, well, that is just equal to 2b squared, because if you multiply plus bi negative 2bi, you will get negative 2b squared I squared, and then I squared just equals negative 1. So this simplifies to 2b squared negative 1, which just gives you plus 2b squared. So that's how you work that out. And now we can simplify this. So we can see that we have a negative b squared and plus 2b squared. So that is just 1 plus b squared. And then we have a negative 2bi plus bi. So that is plus bi. And then we have a negative, no, sorry, that should be negative bi. And then we have negative b cubed I. Now we can separate the real and imaginary parts. So we will be left with 1 plus b squared plus I negative b cubed. So that is the answer for part A. And then for part B, it says that given that the argument of Z1 times Z2 is pi by 4, we need to find the value of B. So to solve this, let's head down to this diagram over here. So we've been given that the argument of Z1, Z2 is pi by 4. This means that our complex number is in the first quadrant. So let's say that our complex number Z1, Z2 lies over here. And then we've been given that the argument of Z1, Z2 is pi by 4. So we can then transform this into a right angle triangle where we have this labeled as pi by 4. And this part right here is the real part of Z1, Z2. And this height over here is the imaginary part of Z1, Z2. Then to find the value of B, what we can use from here is the tangent ratio. So tan of pi by 4 will equal to the imaginary part of Z1, Z2 divided by the real part of Z1, Z2. So I'll just write that down. Imaginary part of Z1, Z2 upon the real part of Z1, Z2. And then we've already worked this out in part A. The imaginary part of Z1, Z2 is negative b cubed. And then the real part of Z1, Z2 is 1 plus b squared. And then tan of pi by 4, well, that just equals 1. So now we have an equation in terms of b that we can solve for. So I'll simplify this. So this is 1 plus b squared is equal to negative b minus b cubed. And then we can move this terms to the left hand side. So we get b cubed plus b squared plus b plus 1 equals 0. Now we don't have an access to a calculator in this exam. So one way to solve this cubic is to take b squared common from these two terms. So we left with b plus 1. And then from these two terms we can take 1 common. So this is 1 times b plus 1 is equals 0. And then from here we can factor out b plus 1. So we'll be left with b plus 1 times b squared plus 1, and that equals 0. Now using the null factor law, either b plus 1 will equal 0 or b squared plus 1 will equal 0. And in the question we've been told that b is a real number. So if we try to solve b in this equation, we will get a complex number. So we don't work with this further. So we just work with this one right here. So we get that b is equal to negative 1. And that is how you solve question number 9.